Very good morning, great hopes. I hope that you had a wonderful time looking at the questions we're dealing with last time. I'm Rollins, and we are back again for our math session, which is a Smart Caps lessons, proudly sponsored by VT Africa Holdings, the DBE, and different other sponsors. Today, we are going to be proceeding with the last part of our trigonometry, which I'm sure that you know that trigonometry is one of the great topics, which is a lot of marks, and you need to actually do your best to score so much in this particular topic. So in that regard, we are going to be looking more into three-dimensional trigonometric problems, which is one of the areas that even science is emphasizing. There are 3D movies, there are 3D simulations going on, so you do well to actually have all the concepts for 3D that would help you to understand the world much better. Again, I'll remind you that there will be some in-lesson assessments which you can easily access by using your device to go to www.hellosmart.com. So as on the screen, www.hellosmart.com, you'll be able to access our free lessons. You simply need to have a smart device, which can be a phone or a laptop or even a PC. When you do that, you see that you'll be asked to sign up. Just choose to sign up as a guest, and this is the ID number. So you do have the ID number, which is in red, which is your 598751. So I will flash this number again when we do our assessment, just to remind you, but you can take this number. We'll always be using it for the time being. You can also add your name as is required on the very quick login details that you fill. Having said that, let's go into our lesson. Last week, we started to look into the cosine rule, and we mentioned that the cosine rule is more useful wherever you have a situation of side, angle, side, which we said the angle here is an included angle between two given sides. So for a question like this, what is the minimum information needed to use the cosine rule? The size of all three angles, which would mean S, or the lengths of two sides and the angle between them, which is that is your B. Then if we had to consider C, the sizes of two sides and their respective angles. So this would be like side angle. So that's too much information. Remember, we are looking for just the minimum. And the last question, which is D, the last solution there, D would be the size of one side and one respective angle, which is side angle. That's not enough information to go by in solving a triangle. So that kind of reminds you of what we were doing. Let's look at the question I left as a homework for you. If CE is 21, where is CE? Right here on the side. That's 21 centimeters, which tells us straight away that because this is an isosceles triangle, the side CD is also 21 centimeters. And we told that angle C is 37 degrees. So this is information that is given, and we are asked to find side DE, that as well as the angle at D and at E. Okay. So since we are given one of the angles of an isosceles, it means we can easily find the other two angles. So one of the ways to do that would simply be to say that the sum of angles in a triangle is actually 180. So if we had subtract 180 minus 37, and then that would give us these two angles, because that's the remainder from removing the angle C. And then we divide that by 2 since we have equal base angles. So using your calculator there, you'd see that you start by the subtraction, then you divide by 2. So you could get something like 71.5, which would be your angle here, as well as your angle here. So these angles are equal as much as the sides are also equal. Okay, so that takes care of it. Of course, you could almost start to pick that your answer is at A because of your D and E, but we still need to find DE, the length, the side. So to find DE, we could say DE can be given the name small c because it's opposite to C. So if you notice, we have quite some information on this triangle, and we could use the cosine rule, which would be that C squared equals 2. So this is E, this is D. So C squared would be D squared plus E squared minus 2 DE cos C. So we talked about this formula last time, and it's a matter of substitution here, where we have 21 squared plus 21 squared minus 2, 21, 21 cos 37. Okay, so in the end, you get a certain figure that you must find the square root of to get your C, and that should give you DE equals to 3.33, which is 13.33 centimeters. So let's check if that would be the answer. Yes, so the answer would be A for this particular question. Okay, great, prof. So I believe you managed to get through with this question and found the solution to be solved. So this was our homework. Let's also mention the other question I gave you for your homework, which was a compound triangle, because it has two triangles married together, which makes the angle X, Y, and Z our unknowns. In this regard, we can start by looking for X, which we can notice that in terms of X, we have a side followed by an angle followed by a side. So to find X, we can simply say X squared is equals to, so you might have to give names to these sides, your 7 and 5.1 and 60. You see that the diagram doesn't have names. You might want to give names. You can give any name arbitrarily. It means any how you like. You can just say PQ, RS, like that. And so eventually you'll see that there is a point in finding x where you have this point that 5.1 squared plus 7 squared, because you take these two sides that in the included angle, and then you have 5.1 and then 7 cos 60. So at that point, you will get your x to be something around this 6.27 to 2 decimal places. Okay. So as I said, whenever you have a diagram and you found some solution of it, and you're still proceeding with that diagram, populate your information on the diagram, meaning do fill in that information on your diagram because you might need it for the next challenge. And that's true in terms of y. We are now looking for y here. And to get y, we have to use the triangle QRS. And as you can see, we have 3 sides given. In other words, we have side, side, side in that triangle. So to get our y, which is an angle, we need to make sure that y is in between the 2 included angles. So to do that, we can even start with x squared equals to, then we have these 2 other sides, which is 3.8 squared plus 4.6 squared minus 3.8, 4.6 times cos y. Okay. So in this case, our small x is actually an angle of y. So hence the difference in the letters. So it could have been big y here and small y here. But being that it's an unknown angle, we use a y, another letter. Okay, so x, which is the side, is the side opposite your y, which is the angle. So if you do this, you will see that we already have this x squared. We already have x from our previous working, and so if you substitute that x and you make cos y the subject, eventually you find your y being 96, as you can see right there. So you need to find your arc cos of y, and then you get your y. To get your z, z is also an angle, and since that you have your y, which is 96 degrees, which you must populate on the diagram. To get your z, you can use the cosine rule. You can also use the sine rule. You have a lot of options to use here. So you could opt to use the sine rule is by comparison a bit quicker than the cosine rule. So given an option, you can just use the cosine rule, rather the sine rule in comparison with the cosine rule, because the cosine rule needs you to still use the trig function cos as well as to find the square root. So that's sort of an extra part, whereas the sine rule is only the trigonometry, the trig function only. So you would have something like sine sine z over 3.8, because remember, the sine rule works with the opposite side. So you look for opposite side to an angle, and then we look for a pair that is given. So I would take sine 96 over x, which is 6.27. So with this, your z will give you that answer. So as you can see, our answer that I trust you got was D. So D would give you all these solutions as we have checked it like that. We have barely just used our cosine rule as well as sine rule in solving this compound problem. The last question that I can give you in this cosine topic that we are dealing with is simply calculate the area of the triangle. So just to remind you, the area of a triangle is given by, area is half AB sine C. In other words, we need a side, angle, and side, more like the cosine rule. So we need a triangle that fulfills that we are given a side followed by an angle followed by a side. In this regard, we don't have a side. Yes, we have an angle, but we cannot there's no side and there's no side. So we have not enough information to actually go by to solve this particular question. So D would be our solution. There is no enough information given to solve the area of the triangle. Okay, that's good. Let's now go into the business of the day. And I want to leave you with one question that you can start to think about if you've done Euclidean geometry. You have a circle, and this is a diameter. So your diameter is there. And then you have something subtended. So we will deal with Euclidean geometry, but if you have already covered it, you will know that there is a 90-degree here because the diameter of a circle subtends 90 degrees to the circumference. So that's 90. And since these are equal sides, because it's an isosceles triangle, and we are told that this is 16. So yours is simply to find these two sides. So a good hint for you is that, let's say this side is A, this will be A as well, because they are equal. So you would have Pythagoras coming into play here. 16 squared equals to A squared plus A squared. Because 16 is our hypotenuse, which is opposite the right angle. So in the end, we have something like 2A squared, 16 squared, and then you're going to use your calculator to actually get your A. And when you get your A, you then come back to use it on the area of a triangle. This is a right angle triangle, so you just say half base times height. So it will be half. Your base would be that A, and your height will be that A as well. So once you have found A, come and substitute it here and here to actually get your area. So I trust that you can work around this and get to a satisfying solution. Okay, so this is something in where we are preempting the topic of Euclidean geometry. And if you have covered it, I'm sure that you will be comfortable to look into this question. Okay. Today we are measuring on solving problems in 3 dimensions. So when you are solving problems in 3 dimensions, we definitely are dealing with very practical situations because the world is in 3 dimensions. Though we usually convert the 3 dimension to 2 dimension for simplicity, but otherwise, when you are watching your TV or your computer, their images, they are actually representing 3-dimensional world. So 3 dimensions simply means something with length, width, and some depth or height. So it has 3 of these: length, breadth, and height. So that will be 3 dimension. Most of the problems we're gonna solve, I want you to have this in mind. So this will be very useful. Solving problems in 2 dimensions or even 3 dimensions, you must apply these rules that when working with trigonometry on real world problems, the angle from point A, the observer, this angle here, to the point B, the object, is known as the angle of elevation. So it's labeled right here. So the angle of elevation is at the bottom, and then the angle of depression is the angle from point B to A. So that on the top is the angle of depression. In other words, you are looking down. So depression means down, isn't it? When you are depressed, you are down, your mood is a bit low. So the angle of depression is that which is looking down. And the angle of elevation is looking up from the horizontal to a certain point up at a certain distance. You're going to relate to this diagram as we go into the questions. This is an example where we want to solve problems in 3 dimensions. So here is Sam. She is sitting 15 meters away from the base of a tower. I would like to just annotate a bit on this. So she is 15 meters. I hope you can see this on the picture. If Sam is looking up at the tower at an angle of 67 degrees. So she's looking up at the tower. How tall is the tower? Okay, so the good thing about these problems that have to do with elevation and depression, just tell yourself in mind that most of them, they relate to the 90-degree triangles. So in that regard, it means you can use your trig functions and your Pythagoras. So in this particular case, we are looking for this whole distance from here. If this is maybe the top, and then this is the base of the tower, and this is same here, we are looking for that TB, that whole length of the tower. And as you can see, it's an opposite side to the angle given. So the angle given is opposite to that height TB. So we can easily use some trig function that involves opposite, and we are also given here, which will be an adjacent. So for example, to find TB here, would use the tan function. So you have something like tan 67 equals to opposite, which will be TB, the one we are looking for, over 15. So you do make TB the subject of formula, you get your side TB. But let's look at the working of it so that we can easily follow it as we go. So going into the solution of it, yes, as you have just mentioned here, we used TB, but the solution here is H, which is the same. So the height H, which is our TB on our diagram, you can easily get your H or your TB as 35.34 meters from same. So same is seated 15 meters, but the whole tower is 35.34 meters. So it's good to label this on your diagram because you might need it for the next question. Okay. The next question says 4.2. It says, what is the distance directly from same to the top of the tower? So we are looking for the distance here, which I've annotated as ST. So what is that distance? And as you can see from the solution, because that we have an opposite side, we have an adjacent side, we have an angle. We are kind of spoiled for choice because you could use the Pythagoras to find this hypotenuse since you have the other two sides. You could also use the sine function since you have opposite, and you could also use the cosine since you have the adjacent. But usually in a situation like this, the best option is to use the numbers that are provided in the question. So let's say we had made a mistake in finding our TB or H, which was 35.34. It would be safe not to use it for another question because we would now multiply that error in another question. So if given a choice like this, you rather avoid your answer because obviously this 35.34 is correct, but the 34 part of it is an approximation, which means we lost a few degrees of accuracy, and it might slightly affect our answer. So in this case, you would rather choose your 67, it's provided in the question, your 15 is provided in the question, so you use cos. So cos 67 would give you, cos 67 is going to give you 15 over r. So in this case, you can see that this was given a name r. As I said, you can name this arbitrarily, which means you can actually give names that you like. So if this is r, our st, we can use the cosine to find r. Okay. So it's also shown in a diagram here that if you have your h, which we don't know, and your 15 and your 67, then you're looking for r. You can use the cosine function. So R eventually is 38.39. You might put that on the diagram in case you need it for the other question. So the last question on this says, the tower casts a shadow that is 25 meters long. If the shadow falls at an angle of 120 degrees away from SEM, what is the distance from SEM to the end of the tower's shadow? So another aspect of this kind of questions, there's a lot of English. As you can see, the paragraphs of the question. So you need to listen carefully as you read the question so that you don't miss some subtle or hidden information in the process. In this case, we are told that the tower casts a shadow that is 25 meters long. So this is this part which is annotated in red on the side. And that shadow is at the base, of course, so it's 25 meters long. And then this shadow is at an angle of 120 degrees away from SEM. So from SEM, this angle here will be 120 degrees. So to sort of show it in a more clarified diagram, here is a part diagram showing you the arrangement of SEM, the base, and the tip of the shadow. So as you can see, the information given, we have a side angle side, which would give us to use the cosine rule because we are looking for D here, that distance from SEM to the end of the tower's shadow. So to do that, we can use our cosine rule, which we've been using, and it will give us D equals to 35 meters. Wonderful. So I'm sure that you following this. Questions that are banking on the trig function are generally easier to solve with regard to not using much of the cosine rule, the area rule, and all that. They kind of straightforward. So you shouldn't be put away by a lot of wording that comes in the question, but you must rather continue to focus on what diagram can simplify all that. So as you can see, the whole narration that we get in question 4.3 that we have just done, a whole paragraph is simply summarized in this little diagram. So that diagram helps us to picture everything that is being narrated in the question. Okay. Now, let's give ourselves a challenge now to solve one of the questions. So question 15, we want to look at it in this way that if we have a diagram that is given, which angle is the angle of elevation? So those people who are using gadgets want to flash that number again for you to remind yourself that you need to go to hellosmart.com, hellosmart.com, and then you sign up as a guest and you use the ID number 598751. Then you put your name as you join the session, and voila, you are already in the mix. Okay. Those that are using gadgets, I'm just connecting you in a second. you should be able to get connected just now. But if you're not using a gadget, you could already be answering this question by simply using your note page. You can actually just work with the information that is given and start to find out what you can actually do. Okay. All right. So that should give you a good enough time to have looked at the question already. In the diagram, which angle is the angle of elevation? So those that are already connected, it's just a click away to your answer to choose between these three angles given in the diagram. Is it the angle 40? Is it the 50? Is it the 90? So you choose. So as we already said, the angle of elevation is the angle of right here, where you can look up. So if you look up, you're at the ground, you're looking up. This is your eye there. So the angle there is the angle of elevation. So your answer should be D in this case. Let's review the answer for your sake. And yes, it is D. Let's proceed to another question. So another question is, two tourists are looking at a statue that is 93 meters tall. The first tourist is looking up at an angle of 50, and the second tourist is looking up at an angle of 35 degrees. Who is closer to the statue and by how much? Okay, so if you are using your device, you are already able to see this question, I trust. And there is a diagram already showing us. So this would be this would be your okay. This would be the two tourists. So the one is 50 degrees and the other one, the angle of elevation is 35 degrees. You could also put these ones into sort of a two-dimension arrangement like this. And then you have 35 will be a smaller angle, so that will be this one, whereas 50 will be the bigger angle. So that's also another representation of the same. So obviously, the tourist who is at 50 degrees is closer to the tower, your tower being that vertical line. So your choice would be that it's the first tourist because that's the one at 50 degrees. And then you want to check how far that tourist is from the tower. Who is closer to the statue? This is a statue, this one, and by how much? So you want to find this distance here. Okay. Meaning that the information that we are given is that this is 93 meters tall. And you already have your 50 here. So you can use that, your 10, 50 degrees equals to opposite, which is 93 over what we are looking for. So if this being a statue, if this is S, this is A, this is B, just some choice of letters here, then you are looking for AB in this case. So by transposing, your AB should give you something like 93 over 10, 50. So from your calculator, you should be able to get a solution simply by putting 93 divided by 10, 50, which I trust that it should give us the 55 meters. So that means this distance is 55 meters. Okay. And that will be your solution A. All right. As we are nearing the end of our lesson, let's try to cover one of the last questions. One of the last questions here is, we have an interesting scenario where we have a waterfall represented by this diagram. So let me read the question. Line AB represents the flow of water that of a river, and BD represents the drop. So this is where the waterfall, and of a waterfall that is 102 meters high. So that means this is 102 meters, 102 meters. Point C is where you need to stand if you don't want to be splashed by the water. If BC is 120, so this is 120 meters. If it's 120 meters, find the distance of this point from the base of the waterfall. So this point is, we are talking in the reference to C. Yes, it's also mentioned there that we are looking for CD. So as you can see, CD is in a right angle triangle because of the 90 here. So things are easy for us. We can almost use a couple of options because we have two sides given, we have an angle. So you can use this cosine rule. You can use just the cosine function as well as 10. So 10 would be 1058.21 degrees equals to BD over CD, which is equals to 1058.21 degrees. So BD is given already as 102. We are looking for CD. Okay. So you need to just transpose your CD, comes on top. These two can exchange, but you can use your method of cross multiplying and all that. You will see that in the end you have your 102 over 1058.21. Okay. So that should give you a particular value of CD from your calculator. And if you get that CD, put it on the diagram, you might need it. Then the last part of the question is saying, What is the angle of depression of the waterfall? A, B, C. Okay, so depression means we are looking down from the top. So from the top, if we look down, the angle of depression is that. So the angle of depression is usually equal to the angle of elevation if we are talking of the same 2 points. So this being a Z angle, this angle will also be the same as this. So these angles are forming a Z angle, which is an alternate angle. So that means the angle of depression is also 58.21 degrees. Okay, so our solution to all this is B. So B happens to have everything that we want, which means our solution to that CD was then 63.21 meters, and our angle is 58.21 for the angle of depression. That was quite a good one and very practical, as you can see. And then to leave you with something interesting, you can look at the Nelson Mandela Bridge, which is in Joburg City, and you have the picture there. You are given a diagram to make it easier to understand. So if the bridge is 27 meters tall and 284 meters long, what is the length of the longest cable on the bridge? So I'm sure that you'll be able to divide this by 2 to get just a triangle. This is 90 degrees. You are looking for X, okay? And you know that this is 27 meters. So use your different information that you have. For example, you might use Pythagoras or the trig function to get your X. And with that, I would want to thank you, great hopes, and I trust that you are doing very well in reinforcing this concept in your time. Thank you very much. All the best.